Hello everyone, my name is Leonard Faille. I am a lead R&D engineer at Hoeven Horticultural projects, and some of you might know me as a team captain of Team Automatoes from the Autonomous Greenhouse Challenge, which is what I will be talking to you about today. Let me get my slides out. But before I can do that, I need to explain you just a bit on who we are, because it's really important to understand why we're doing this. Don't worry, this won't be a commercial sales pitch. We at Van der Hoeven, we specialize at designing and constructing large-scale, high-tech greenhouses, mostly semi-closed greenhouses, and often a combination of something else like the solar concentrate facility that you see at the left. We don't have our own facilities. We're not producing anything. So we are really, and keep that in mind, we're really system integrators. That's who we are. So on to the Autonomous Greenhouse Challenge. And for those of you who don't know what it was about, I'll try to explain that very fast to you. We were growing tomatoes, and we were not just growing kilos of tomatoes, we were also producing high quality tomatoes. So a combination of kilos and quality would give us euros. And those euros can be spent on resources like electricity, heating, CO2, labor, and plant material. And what we were doing in this challenge was using computers and algorithms to send set points for these resources to the actual greenhouse, which was in Bleiswijk, and in that way try to grow more and better tomatoes, with the end goal being to optimize profit. So that's just in a nutshell what the challenge was about. What's important is that this wasn't just us, it was really teamwork. The team Automatoes consisted of different people with different expertise from 4 different organizations. So there was Van der Hoeven and Hogendoorn, the climate computer company, on one side with a lot of experience in the horticultural industry. And on the other side, there was Delft Technical University and Keygen with a lot more knowledge on AI. And that's really important if you want to do this. It was a really strong combination. I think you heard about the results, and we were really, really proud and honored to be winners in all 3 different categories, actually, of the 2020 Autonomous Greenhouse Challenge. And you're probably wondering, why did we win? And it's partly explained by this graph that I'm showing at this moment. I'm showing the graph of the kilos of production in time, and the orange line is our line. And what you can see is we were producing a lot of tomatoes. We were actually producing most kilos of all teams, but we also produced them at the right time, because we knew that the prices were the highest in March. And exactly at that time, we produced a lot of tomatoes of high quality. So that was really important factor in winning. So we produced a lot, but it was not just producing a lot, we were also really efficient. So we used very little heat compared to the others, and we used low electricity, very little CO2. And so we were really efficient. That's also really important in why we won. What we were doing is we were always trying to maximize photosynthesis. This is I'm showing you some data from the actual challenge. This data has been released, so you could make this plot for yourself if you want. And what's nice to see is, I call this the growing fingerprints. So you see some graphs showing on the horizontal axis the temperature, and on the vertical axis the relative humidity, and there's a dot for every 5 minutes in time, and the dot is colored according to the CO2 concentration. And that gives you sort of a fingerprint on how the growing climate was over time. And I won't go into detail too much because I only have 10 minutes. It's really nice to see how different those fingerprints are between the different teams. And of course, we are convinced that we were making the best. But I'll try to explain you a bit more on how we did this. I already said it was really about teamwork. So we had a really strong team, which is really important in winning. And then we used some really nice algorithms, some AI from data science, and tried to optimize the set points. And then we also did system engineering, which means that you put all this into a robust and reliable system. Otherwise, it's not going to work. But what always stays the most important, and that's why it's in the middle, is the plant. The whole reason you have a greenhouse is that you have a plant. So we try to optimize on the plant. Now, what does that mean? It means that we were trying to keep balance in the crop. And we split it up into two different balances. So we have the short-term balance, and the short-term balance is influenced by a combination of temperature, radiation, CO2 and humidity. And keeping balance means keeping the right combination of these things. So that's the short-term balance. But these greenhouse climate factors also influence on a larger time scale what we call long-term balance. And the long-term balance in the plant determines whether the sugars that are produced by photosynthesis are used for more leaves and stems or for more tomatoes. And you have to, of course, keep balance between those two. So we split it up into those two balances. And if you look again into the system that we built, you recognize here, I cannot go again into too much detail, but you recognize here the short-term control and the long-term control. So this is just a bit on how we did it. So what's the work that we need to do now? And obviously, some steps are really obvious and we're already taking them. So we need to go from just one crop, tomato, to all the other crops, cucumber, soft fruit, lettuce, and so on. So that's a step we're already taking. Another step in our philosophy is that we go from a conventional greenhouse to a semi-closed greenhouse, because we can then bring it to all different climates. And we also think that with a semi-closed greenhouse, you can control the greenhouse climate even better. So we can do even better, be more efficient and produce even more. Okay, that's obvious steps and we're already taking them. And if you try to look further ahead, I think you will agree that we will be not just controlling individual greenhouses, but we will be controlling many more greenhouses. Actually, large investors are already asking us not just to think about one greenhouse. We have to optimize the resource management. So there's a lot more to think about, and that's especially what we at Developent like to do. We like to do system integration. So this is our work. And that brings me to my last slide. What do we need to do to develop this system integration? Well, of course, we need to test. You might have heard this somewhere else, but we'll be doing more and more tests, be it with existing customers to help them with their crop, to learn about this, but also to learn about the other factors such as maintenance and labor. So we'll be doing a lot of testing, of course, and we will be then developing all the individual technologies. And of course, we will not be doing that alone, as I said before. We will be doing that with the partners. That's really important thing to develop all these different algorithms for different parts. And then, of course, our work would be, again, to integrate things. And the really nice steps we can make if we build new greenhouse, new projects, and then we really make an integrated design and bring this a lot further. So, well, that brings me actually to the end of my presentation. Let me just stop that again. I would like to thank you, and I think it's back to the rest of the program actually. Thank you very much.